So lesson 11 homework, we're going to focus on our tangent rules. In the following diagram, QP is 18. Determine the measure of PR and explain your response. Well, the way I look at this, I see QP and I see another tangent from point P to that same circle. So that tells me that PT is 18, right? Because they're both tangent to the same circle from point P. Well, PT happens to be a common tangent between both of those circles. So now as I look at it, if PT is 18, PR has to be 18. So it wants us to explain how we're going to get that piece. And the reason is all three segments are common tangents from point P. So we were able to get our tangent to the same circle rule for QP and PT for the circle on the left. And then since PT is a common tangent to both of them, we're able to do same distance, from point P for the circle on the right. So PR and PT would have the same length. In number 2, lines AE and BD are common internal tangents to circles P and R. And the measure of angle ACB is 60 degrees. So ACB, so that whole angle here is 60 degrees. Determine the length of PR. If PA is 1.25 and RD is 8. So the first issue I see with this problem is that the 8 is in inches and the 1.25 is in feet. So this is actually easier if I put this in all into inches. So 1.25 feet is really 1 foot 3 inches, or in other words, 15 inches. Now as I look at this, they want to know the length of PR. What I'm going to do is I'm going to find PC, and then I'm going to find CR, and I am going to then add them together. So they gave us that this whole angle ACB was 60. Well, we found that those two triangles were congruent. So that really means we have 30 and 30. That basically acts as a bisector. The next thing I'm going to do is recognize that I've got my right angles here. Now, as we go in here, I see the 30. I'm going to use vertical angles to get some angles there. And I've got my right angles where my radius and my tangents intersect. And what I'm going to do now is I'm going to do a little bit of trig. So if I look here, to get x, we'll start at the 30. I have my opposite, adjacent, and my hypotenuse. So I'm going to use my opposite and my hypotenuse, which is sine. So I'm going to be sine of 30 over 1 equals opposite is 15 over x. All right. So we'll cross multiply now. I get x sine 30 equals 15. I will divide both sides by the sine of 30. And I get that x is 15 divided by sine 30 gives me 30. So that tells me the length of PC is 30. And then I'm going to do the same thing in this smaller triangle. From the 30, I have my opposite, my adjacent, and my hypotenuse at y. So this is going to be basically the same exact setup. The only difference is instead of being 15 over x, I'm going to be 8 over x. Over y. All right. So over y. So y sine of 30 equals 8. I'll divide both sides by sine of 30. Divide both sides by sine of 30. And when I do that and go to my calculator, I'm 8 divided by the sine of 30. I get 16. So now what do I get for the whole length of PR? I'm going to add 30 and 16 together to get 46 inches. Now it doesn't say it wants it in feet or inches, so my suggestion would be just leave it there. In the diagram below, triangle ABC has a perimeter of 30. Determine the measure of AP. Well, common tangents say that if CR is 4, QC has to be 4. And that if BQ is 6, BP has to be 6. And then if AP is labeled as X, AR has to be X. So what do we have now? If this whole triangle has a perimeter of 30, we're x plus 4 plus 4 plus 6 plus 6. That's going to give us 30. So x plus x is 2x. 4, 4, 6, and 6 gives us 20. So we'll subtract the 20 on both sides. 2x equals 10. Divide both sides by 2, and we get that x is 5. So therefore, the measure of AP is going to be 5. Determine, is segment AB is tangent to the circle below? So now what we want to do is, if AB were to be tangent, that means that this has to be a right angle, and therefore we should be able to figure out if this radius is 12 and this radius is 12. If we add those together, this is 20. We should be able to do Pythagorean theorem and have 12 squared plus 16 squared equal 20 squared. Okay, so our Pythagorean theorem should check out here if this is going to be tangent, because then if it's tangent, it will form that right angle. So 12 squared is 144, 16 squared is 256, 20 squared is 400. So we add those together, we get 400 equals 400. So since that checks out, yes, AB is tangent to the circle. If our Pythagorean theorem did not check out, that would mean AB would not be tangent to our circle.